Guys, I arranged this meeting today to talk about our pens. There have been recently complaints about the sizes of them. They're either over or undersized, and we need to fix the problem. To do this, I need you to get the data of all the pens so far in a sample. And I need you two guys to make a chart analyzing the data and get back to me as soon as possible.
Okay.
Okay, now we just come back with 15 sample of data.
Great, let's see what you got.
On the data we calculate, and I made two charts. The first chart is X bar chart, and from this chart we found there are 6 sample out of control, and about the range chart, all of the sample are under control.
The central line of the X bar chart is just the grand mean of all the X's we got. The UCL of the X bar chart is the grand mean of the X's plus A2 times the range, the grand mean of all the ranges. The LCL, or the lower control limit of the X bar chart, is the grand mean of the X's minus A2 times the range. To get the A2, we have to use this chart, and since our sample size is 4, the A2 value is 0.73. So the central line here we have is just the average of all the means that we calculated already from the 15 samples. For the LCL, we use the mean value that we just got plus the A2, which was a 0.73, times the range, the grand range, which we calculated from all these ranges we got, to get a LCL of 13.0214. For the UCL, it's the same formula essentially, except we subtract the A2 times the range values to get a value of 13.975. The control central line of the range chart is just the average of all the ranges we have. The UCL of the range chart is D4 times the grand range. LCL of the range chart is D3 times the grand range.
Okay, question. Do you get the D3 and D4 from the same chart?
The central line of the range chart is the grand mean of all the ranges we got. The LCL of the range chart is D3, which the value is 0, times the grand range, so the value is 0. LCL of the range chart is the D4 value of 2.28 times the grand range to get a value of 1.489. That comes to a close. Do you have any questions for me?
Yeah, I have a question. What's the standard deviation of this control chart method? Is it accurate enough?
The standard deviation is 3 sigma, and that's roughly 66,807 defects per million.
Okay.
I have a question on how to handle this problem.
We're going to have to change machines, probably get a newer model. Hopefully that will reduce the amount of defects we have.
Impact the result if we change the sample size?
Yeah, if we increase the sample size, the data we get should be more accurate and closer to reality.
Okay, now we got new machine and a new data set. That's all here.
Okay, based on our new data, we made 2 charts, and the first chart is the X bar chart, and look at this X bar chart, all of the data are under control.
From the red chart, we can see the data also uncontrolled.
Good job, guys. It was a great success.